Waiting for mortgage rates to drop could be a costly mistake. Once rates drop, new homebuyers will enter the market and prices will soar even higher. At Churchill Mortgage, you can get a free analysis and learn how to avoid the trap of waiting for interest rates to drop. Buy now and refi later at churchillmortgage.com. This is a paid advertisement. NMLS ID 1591, NMLSconsumeraccess.org, Equal Housing Lender, 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027. Waiting to buy a home? The Churchill Mortgage team says now is a great time to buy. Waiting could be a costly mistake because when rates drop, new home buyers will flood the market, driving up home prices. Go to churchillmortgage.com for your free analysis and see how home values can outpace rates to help you build wealth over time faster. This is a paid advertisement. NMLS ID 1591, NMLSconsumeraccess.org, Equal Housing Lender, 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
This is SpaceTime, Series 23, Episode 137, for broadcast on the 21st of December 2020. Coming up on SpaceTime, the death of a star devoured by a black hole, scientists begin to study the samples from the asteroid Ryugu, and the first direct image of a newly discovered brown dwarf. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have captured the dying moments of a star just as it was being ripped apart by a supermassive black hole 1 million times the mass of our Sun. The violent event, known as a tidal disruption, occurred just 215 million light-years away, making it the nearest such flare ever recorded. A report in the monthly notices of the Royal Astronomical Society claims the catastrophic event will help scientists better understand supermassive black holes and how matter behaves in the extreme environments around them. Tidal disruption events occur when a star ventures too close to a black hole. It's then caught in the black hole's immense gravitational pull, being crushed, ripped and torn apart in a process astronomers refer to as spaghettification. The stellar debris then forms an accretion disk around the black hole's event horizon, beyond which is a point of no return, where matter falls forever into the black hole's singularity, a point of infinite density and zero volume, where science's understanding of the laws of physics breaks down. Because the gravity of a singularity is so intense, the escape velocity of anything falling beyond the black hole's event horizon becomes greater than the speed of light. And since nothing can exceed the speed of light, nothing, not even light, can escape a black hole once it's passed beyond the event horizon. In the case of this star, as it was being torn apart, about half of its mass fell into the black hole, disappearing forever, while that remaining in the accretion disk was heated by intense friction, releasing huge amounts of radiation and generating powerful jets of stellar material ejecting outwards. These events are often obscured by a thick curtain of dust and debris, which has made it difficult for astronomers to see what's happening, until now. See, astronomers know what should be happening in theory. When a star wanders too close to a supermassive black hole at the center of a galaxy, the extreme gravitational pull of the black hole shreds the star into thin streams of material. And as some of these thin strands fall into the black hole during the spaghettification process, a bright flare of energy is released, which astronomers can detect, the final death knell of the star. Although powerful and bright, astronomers up until now have had trouble investigating this burst of light because it's so often obscured by the curtain of dust and debris. But thanks to these new observations, astronomers have been able to shed light on the origin of this curtain, finding that as the black hole devours the star, the energy it releases propels the star's debris outwards. The tidal disruption event, catalogued as AT2019-QIZ, was detected shortly after the star began being ripped apart and destroyed by the black hole, creating this spectacular blast of light. Astronomers quickly pointed the European Southern Observatory's Very Large Telescope, the VLT, and the New Technology Telescope, the NTT, both located in Chile, at what appeared to be a new flash of light occurring close to a supermassive black hole, allowing them to witness the spectacle as it unfolded. The event happened in a spiral galaxy in the constellation Eridanus over a 6-month period as the flare grew in luminosity and then gradually faded away. The observations over those 6 months used multiple telescopes around the world in order to continually track the unfolding event. And because they caught it so early, the authors were able to actually see the curtain of dust and debris being ejected as the black hole launched a powerful outflow of material with velocities up to 10,000 kilometers per second perpendicular to the black hole's accretion disk. It's provided scientists with a unique peek behind the curtain that's allowed the first opportunity to pinpoint the origin of the obscuring material and follow in real time how it enshrouds the black hole. This was the first case in which astronomers saw direct evidence of the outflowing gas during the disruption and accretion process, which was explaining both the optical and radio emissions seen in previous events. Until now, the nature of these emissions had been heavily debated, but the new observations showed that these two regimes are connected through a single process. Brad Tucker from the Australian National University says AT 2019 QIZ could even act as a sort of Rosetta Stone for interpreting future observations of tidal disruption events.
This was a supermassive black hole in a galaxy, and it was a fairly generic, kind of no-name, relatively small, I mean, not tiny, but it wasn't a massive galaxy, but it was a fairly good-sized galaxy. And it was because of an all-sky survey finding this event and then people cluing on, including my PhD student, Harry Abbott, who used the telescopes at Siding Spring Observatory in northern New South Wales, who was first on it to figure out, hey, this indeed is what we call a tidal disruption event, a supermassive black hole eating a star. Not too dissimilar in size from our own sun. And as it gets near it, the gravitational pull of the black hole starts to rip apart a star in a process we call spaghettification, which is bad for it and good for us to see.
We've seen these things before. What makes this one so special?
So we have been seeing tidal disruption events more and more. The cool things about this one is, it was relatively nearby, as it was at a distance of about 215 million light years. Because it was nearby, it was brighter and easier to study. It was also caught very early. We got onto it not only in the discovery of the event itself early, but realizing what it was, which triggered lots of follow-up from telescopes, mostly using the European Southern Observatory in Chile.
Something like this would also produce gravitational waves?
So something like this would actually produce a very small gravitational wave. You're correct. It would produce a ripple through the massive pooling. Now, it would be relatively tiny compared to some of the gravitational waves we've detected here on Earth. But there is a hope that in the future, as the detectors get more sensitive and we find more of these things, we could pair an event of it with its ripple through space. Because when the star is essentially shredded or spaghettified, part of it is released in a big burst of energy that releases essentially a flare into space that we can detect, and that's what we're observing.
So in the future, it'll become another opportunity to actually see both the gravitational and the electromagnetic waves coming from the single event.
Yeah, I think it's a very exciting possibility because it gives us a lot more constraints and knowledge about the exact system. We can roughly calculate that about half the mass was swallowed up or taken by the black hole of a star about the size of our sun. But you can really feel the effects of how strong the pull is, how quickly in terms of it happens as these stars get near or orbit the black hole, it starts to get ripped apart. But it really depends on its angle, its inclination. There's a few obviously different factors there. And in this case, we also saw all of the stuff left behind as the ripping or spaghettification happened. It leaves a whole bunch of debris around, and we were able to both see before and use telescopes to kind of peer through the debris to see the process unfold. Yeah,
that's an interesting angle. Exactly what did you see as this star was destroyed?
So these things start really energetic, very hot, so very blue in colors, lots of X-rays, ultraviolet blue colors. But over time, we see lots of actually dust. And so this is the stuff that becomes compositions of stars and planets. So lots of this material spewed out into space. And normally we don't know if it's there from the star, the explosion, or for something else. Able to see that actually unfold. And that actually, the whole process took months. It actually took over 6 months for this whole thing to play out, seeing various amounts of elements and features of the star evolving with the time after the destruction. And so normally you just don't get to see that. It happens either so quickly or you just miss it. You don't see the whole process from really beginning of the event to the end unfold, which is always exciting.
So I take it at the start, there's just some of the outer envelope, some of the gas of the star gets eaten up. But then as the process continues, the star's core becomes exposed and that gets destroyed. Is that what we're seeing?
That's right, because these stars have different layers. So you see lots of hydrogen early on, but then you start to see more involvement of carbon in particular and oxygen as well, lines popping up, and then lots of iron, of course, and seeing that changing over time, really, as you said, as the rest of the star becomes enveloped. And in this case, we have to think that obviously if this was a star and it was a solar system, this would happen to the planets as well. We can't detect those in this case, but it'd be safe to assume that there would potentially be planets, or at least at some point around there, and they would go through a similar process and stage.
Tell me about the discovery itself. A number of telescopes were used, a number of papers, I take it, are being written about this.
So lots of telescopes have been used. So there was our telescope at Siding Spring, multiple telescopes in Chile, both the Very Large Telescope using multiple instruments and the NTT, the 3.6-meter telescope in Chile, able to also trigger some telescopes using Keck in Hawaii, and also some space telescopes to kind of get into it. When we see these black hole events, they don't happen that often, or at least we don't detect them that often. The fact that it was caught early and also in a spot where it could be visible both by some facilities in the northern hemisphere and the southern hemisphere was a great chance to jump on it and trigger some space observations, including the Swift telescope as well.
Seeing something like this must be telling us a lot about how stars are made and the sort of physics very close to a black hole, the sorts of things that relativity theory predicts.
And this is, I think, that this exciting thing about seeing these sort of events is because you're literally seeing the event where, we all that talk about the gravity and the black hole sucking things in, you do actually get to see it. You get to see it play out, and really that is just a direct consequence instead of relativity. And actually, as these stars are destroyed and spat out, that gas eventually goes off into space, will be mixed into that galaxy and potentially form new stars. So you really get to see a process playing out that, theoretically we thought happened, it should happen. And you get to see it in this case in a lot of detail, which makes it exciting. And, our view of black holes is dramatically changing. We're getting more and more data and physics and science around the critical parts of the black hole, which 10 years ago we just didn't have that much.
And as the black hole's devouring this star, what's the black hole doing? Is it producing a quasar or gamma ray event or X-rays or what?
So the black hole is producing a little bit of high energy particles, so these gamma rays and X-rays of light, but there's not enough stuff to sustain it into being a quasar. And we think it's a spectrum. We think the big quasars we see early in the universe just have lots of pockets of gas and stuff constantly being destroyed or disrupting the area around it. So it's nice to see kind of isolated events where you can pinpoint exactly, hey, it was an individual star happened or it's an individual event. If we look like a place like our Milky Way, at the center of our galaxy, Sagittarius A star, where our supermassive black hole is, it's relatively quiet. There's not a lot of stuff. And so you can imagine in places like that, if you happen to get a few things producing through it, that this would also produce one of these tidal disruption events if a star got too close.
Yeah, that's a good analogy, actually. When we look at some of the unusual events we're seeing happening around Sagittarius A star now, and there have been some interesting characteristics of late, can we relate that to what we're seeing with this particular tidal disruption event?
And I think that's exactly what people hope to be able to do. Now that we kind of have a pretty good picture of the play out of a tidal disruption event, can we relate it to other bits of activity that we can see in our own galaxy? And I think that's what our hope for this thing. In fact, a lot of the co-authors in the paper said this might be able to be a sort of Rosetta Stone for these sorts of events because we got so much data and information on it. Starting to put together a bit of that picture. Because anything that happens near our galaxy, we'll see, fainter or smaller features or funnier objects or, smaller characteristics. So we can hopefully figure a little bit out about what's going on. And then also what happens just in all these other galaxies. If every galaxy or every decent-sized galaxy has a supermassive black hole, these things should be happening quite a lot. Are we missing them? Are we not looking right? What are the questions? How do we find them? How do we know more about what's going on?
Yeah, so all galaxies should have their own Fermi bubbles and things like that.
That's right. That's what we think. They should be doing this. They're usually just so far away, hard to detect. So how can we put the picture together of what is happening at the center of our galaxy? What do we see in these individual or isolated events in some galaxies to see kind of, the full picture of what black holes get up to?
And as an astronomer and astrophysicist, when you see something like this, what goes through your mind? What feelings do you get?
Well, look, I think it's really exciting because, these things are found because there's these all-sky surveys monitoring the sky looking for changes. And sometimes it's a cool supernova. Sometimes it's just a flare star. Sometimes it's just erroneous junk. It's just a mistake. So you kind of have to sift through the data to find the good one. And so by showing that the program that my student Harry set up to kind of find what we think are the good ones, or at least find the ones that are early enough to do something exciting with, kind of starts to pay you back that, hopefully you can sift through the noise and find those really gold and special events that really tell you a lot about the universe, and this is what happened this time.
And as soon as that happens, everyone drops the science they're doing and they just swing their telescopes around and look at this thing.
That's the exciting thing. That's right. The alert came from Trilly. We were on it, said, hey, it's a tidal eruption event, Hawaii on it, and then, everything is triggered. And as he said, you pour all your time in, because you have such a short amount of time. We're so used to things in the universe taking millions of billions of years, but when these things happen days to weeks, time is of the essence in this case, and if you miss it, you miss it.
That's Brad Tucker from the Australian National University. And this is Space Time. I'm Stuart Gary. Still to come, scientists begin their study of the materials brought back from the asteroid Ryugu by the Hayabusa 2 mission, and the first direct image of a newly discovered brown dwarf. All that and more still to come on Space Time. Scientists have described samples of the asteroid Ryugu returned to Earth aboard the Hayabusa 2 mission as looking like black sooty sand. These initial impressions come just a week after the spacecraft's sample return capsule parachuted down into the Woomera rocket range in outback South Australia. It follows an unprecedented 6-year mission by the Japan Aerospace Exploration Agency JAXA to the kilometre-sized asteroid located some 300 million kilometres from Earth. Mission managers were aiming for around 100 milligrams of sample material, and they're pleased to say that they definitely got that. Asteroids like Ryugu are believed to have formed at the very dawn of the solar system 4.6 billion years ago, and so its samples may contain organic matter that could have contributed to the formation of life on Earth. Scientists hope the samples, which include both surface regolith and pristine material from deeper inside the asteroid, will shed light on the origins of life and the formation of the universe. This is Space Time. Still to come, the first direct image of a newly discovered brown dwarf, and Russia launches its new heavy-lift Angara A-5 rocket. All that and more still to come on Space Time.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
We've locked in low prices to help you save big store-wide. Look for the locked in low prices tags and enjoy extra savings throughout the store. Baker's, fresh for everyone.
Astronomers have directly imaged a newly discovered failed star called a brown dwarf. Researchers using the Subaru and Keck observatories atop of Mauna Kea in Hawaii imaged the brown dwarf named HD 33632AB orbiting a sun-like star in a binary system 86 light-years away. The findings, reported in the Astrophysical Journal Letters, could provide scientists with key reference points for understanding the properties of the first directly imaged exoplanets, that is, planets orbiting stars other than the Sun. Brown dwarfs are failed stars, objects which don't have enough mass to sustain the core hydrogen fusion process which makes stars like our Sun shine. Brown dwarfs fit into a category between the largest planets, which have about 13 times the mass of Jupiter, and the smallest stars, spectral type M red dwarfs, which can be around 75 to 80 times the mass of Jupiter, or, to look at it from another point of view, about 0.08 solar masses. While some brown dwarfs are born as brown dwarfs, others start their lives out as red dwarf stars, but then lose enough mass during their evolution to cease core fusion, turning them from red dwarfs into brown dwarfs. The Subaru telescope initially detected and imaged the object, triggering follow-on observations using both Subaru and Keck. The Subaru data showed that the brown dwarf's atmosphere could contain water and carbon monoxide. The study's lead author Thane Curry from the Subaru Observatory says the incredibly sharp images provided ultra-precise measurements for the brown dwarf's position in the spectrum, and this provided important clues about its atmospheric properties and dynamics, and similar techniques could be used in future to study exoplanets. Meanwhile, the Keck telescope obtained infrared images which confirmed that the brown dwarf is in a binary system with a Sun-like star catalogued as HD 33632AA, and it's not simply an unrelated background object. The observations show the brown dwarf and its Sun-like companion star are separated by about 20 astronomical units, an astronomical unit being the average distance between the Earth and the Sun, about 150 million kilometres. And 20 astronomical units will be sort of similar to Uranus's orbit around the Sun. Meanwhile, data from a third observatory, the European Space Agency's Gaia Space Telescope, was able to determine the brown dwarf's mass, finding it to be about 46 times that of Jupiter, the largest planet in our solar system. This is SpaceTime. Still to come, Russia's new heavy-lift Angara A-5 rocket takes to the air. And later in the science report, the first COVID-19 vaccines start rolling out to recipients in the United Kingdom and United States. All that and more still to come on SpaceTime. Russia has conducted a successful second test flight of its new Angara A-5 heavy-lift rocket. The launch from the Plesetsk Cosmodrome 800 kilometers north of Moscow carried a Breeze M upper stage and a test payload. The mission took place nearly 6 years after the maiden flight. Named after a Siberian river flowing out of Lake Baikal, the three-stage Angara is the first of a new family of launches to be built since the collapse of the former Soviet Union. In its most powerful A5 version, the Angara will carry up to 24.5 tons into low Earth orbit and 7.5 tons into geostationary transfer orbits. Like the smaller Soyuz, the Angara is fueled by traditional liquid oxygen and kerosene rather than the highly toxic unsymmetrical dimethylhydrazine used in hypergolic rocket fuels which power Moscow's current Proton heavy-lift workhorse. This is SpaceTime.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
We've locked in low prices to help you save big store-wide. Look for the locked in low prices tags and enjoy extra savings throughout the store. Baker's, fresh for everyone.
And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The University of Queensland and CSL have abandoned their trials of an Australian COVID-19 vaccine after recipients began generating HIV antibodies during Phase 1 tests. The reason is the vaccine contained a small protein fragment from the human immunodeficiency virus HIV. It posed no risk to human health, but it meant the antibodies produced by the vaccine could interfere with HIV diagnostic tests, causing false positives. There was no possibility of the vaccine causing an HIV infection, and routine follow-up tests confirmed that no HIV virus was present. Meanwhile, the United Kingdom and the United States have started administering Pfizer's new COVID-19 vaccine to senior citizens and frontline health workers. Australia, which is one of the world's lowest rates of COVID-19 infection, will wait until March next year before mass vaccinations begin, with the government saying the elderly and most vulnerable will be the first to receive the jab, followed by frontline health workers, and then those in essential jobs. The Pfizer vaccine, which is 95% effective, was the first to be made available to the public, followed by the Moderna vaccine, which protects 94.5%, but remains stable at minus 20 degrees Celsius for up to 6 months, compared to the Pfizer vaccine, which needs to be stored at minus 80 degrees Celsius. Both are mRNA-based vaccines, using a snippet of the coronavirus genome to encourage antibody production. Amazingly, it took just a year to develop these vaccines under US President Donald Trump's Warp Speed program. A third vaccine, being developed by Oxford University AstraZeneca, remains under testing, with preliminary results showing between 70 and 90% effectiveness. It's a vector vaccine using a less harmful adenovirus to transport a coronavirus protein spike and trigger an immune response. Both Russia and China claim they also have COVID-19 vaccines, which are now being administered to the public. The COVID-19 coronavirus has now killed over 1.7 million people and infected some 75 million others since first spreading out of Wuhan, China, a year ago. Australia has experienced its warmest spring on record, hitting a mean average temperature of 24.53 degrees Celsius, some 2.03 degrees Celsius above the long-term average. The season began hot, with record warm daily maximum-minimum temperatures in early September, and it finished the same way with an intense heat wave at the end of November. The Australian Bureau of Meteorology have also declared November 2020 as the warmest November on record. At least 20 ground stations across New South Wales, South Australia, Victoria and Queensland recorded their hottest November days in 3 decades. The township of Thargomindah in Queensland broke their November record, hitting 46 degrees Celsius or 114 degrees Fahrenheit on November the 30th. It got even hotter in the outback opal mining town of Andamooka in South Australia, where temperatures hit an all-time spring high of 48 degrees Celsius or 118 degrees Fahrenheit on November the 28th. And Smithville in New South Wales reached 46.9 degrees Celsius or 116 degrees Fahrenheit also on November the 28th, making it the highest spring temperature ever recorded in the state. Mount Everest is officially taller. The new official height of the highest point above sea level is now 8,848.86 metres, according to new measurements by separate teams from both Nepal and China. That's 86 centimetres taller than the 1955 estimate by the Survey of India, which is used by Nepal, and 4 metres taller than China's previous 2005 estimate. However, because the Earth isn't a perfect sphere, Mount Everest isn't actually the most distant place from the centre of the Earth. In fact, it only comes in 10th place. Thanks to equatorial bulge, the furthest place from the Earth's centre is the summit of Mount Chimborazo in the Ecuadorian Andes. It stretches some 2,168 metres further from the Earth's centre than the summit of Everest, even though its height above sea level is only 6,267 metres. Well, a word of warning now, a new study shows that elderly patients going under the knife on their surgeon's birthday appear to have a higher death rate than if they had the surgery on any other day. A report in the British Medical Journal looked at more than 980,000 common emergency procedures on over 65-year-olds. Of the 2,000 operations which coincided with the surgeon's birthday, they found a 23% increase in death within a month of the procedure compared to having surgery on any other day. Researchers say it's similar to the impact of other events like Christmas holidays and weekends, which have also long been argued to affect the quality of care patients receive. Well, this time of year is a time of celebration, be it Christmas, Hanukkah, Sir Isaac Newton's birthday, the solstice, Kwanzaa or Saturnalia. People are celebrating the holidays. And coincidentally, another holiday tradition this time of year is the sudden increase in sightings of a mysterious legendary giant black leopard in the Blue Mountains west of Sydney. The story goes the big cat escaped from a circus years ago. The problem is the same story's been around for at least half a century, and the oldest known big cats seldom reach 30. So it's all a little bit too much like Sasquatch, lots of sightings but no scientific proof. And according to Tim Mendham from Australian Skeptics, when it comes to giant cat sightings, Australians aren't alone, with New Zealanders also reporting sightings of big cats, although probably not the same cat people in the Blue Mountains are seeing. I mean, it couldn't be that big, could it?
Yeah, big cats are popular. Yeah, so New Zealand's had a couple of recent sightings, I think in the South Island mainly, but I mean, it's had its fair share of sightings over the years, as have we, especially around where I am in the Sydney area, around towards the Blue Mountains area. You even have major football team named after the big cats, Penrith Panthers. So, they're prevalent everywhere. The problem is there's a kind of occasional little rare one of people supposedly seeing cubs, but it's mainly individuals that people see running across miles away in the background and saying that's a big cat.
And you have no scale to compare it to. That's the problem.
Very hard. You rarely have one up close, although people have said they've seen one up close, but they don't have any evidence of it. And excuses used is the same old excuses that are rolled out, as you say. Escaped cats either from circuses or from American troops who have a cat as their mascot, either in the Second World War or the First World War, and it gets loose. And this crops up all the time. And the same theory crops up here in Victoria. I know for specific examples where people have said, it's American Army came during the Second World War and their cat got loose. In the New Zealand, one of these cases has been attributed to the First World War. They were unloading their stuff off a ship and they dropped the crate and the crate burst and this cat ran out and got away and no one bothered chasing it.
Must be 2 cats, surely.
Look, that's the whole trouble. You need actually more than just 2, otherwise you get very inbred cats. But if you've only got 1 cat, it's not going to go very far. I don't know what the lifespan of a puma is, but they don't get very far, and they've got to have 2 or more. If you only got 2, they get very inbred. If you've got more, you're bound to sort of spot them somewhere. If you have a population of 20 cats running around in the outskirts of Sydney, I think you'd get more than just a bad photo of them. But obviously don't, so you wonder, well, what is it? And by and large, it's misattribution of feral cats.
A big fat house cat or a big fat feral cat.
Yeah, that's highly likely what they're seeing. Sometimes people say they're seeing a dog or a fox. They tend not to be that big. They tend to have different tails as well.
Well, everyone's got their own
build.
story.
But, it's nice to know the Kiwis have the same sort of experiences as us.
Probably says something about human nature that every time they see a big putty cat, they think, must be an escaped leopard or something, as opposed to simply, that's a big, well-fed pussy cat.
Yes. In the UK, they tend to have black dogs with glowing eyes. I don't know how many cats they have. We tend to have cats, apart from the yowies and things like that. We tend to have cat more than big, scary black dogs.
Yeah, but it's always a big black dog that ate your homework. It's never a cat. That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.